Hello, everyone. Today I'm going to help you with the new assignment, which is called Boyle's Law Calculations. We are moving on into the gases lesson. Now, this requires the equation P1 times V1 equals P2 times V2, where P is the pressure, 1 is the initial value, volume is measured in liters, V represents volume. 1 is the initial volume. So initial pressure times initial volume equals final pressure P2 times final volume V2. Okay, pressure can be measured in any one of these units: ATM, kilopascals, PSI, torr, mmHg. I will help you understand the reason behind this equation. What Boyle's law is saying. Boyle's law says that when you increase the pressure, the volume goes down, and when you increase the volume, the pressure goes down. So they are opposite, they are inversely proportional to each other. So you should have two values of pressure, pressure 1 and pressure 2, given in the question, two values of volume, volume 1 and volume 2, so you can compare. And in these questions, there would be four variables. The one of the variable would be unknown. The other three would be given to you. So you can solve for the unknown variable. So let's go over this question. A sample of oxygen gas occupies a volume of 2.5 liters at 740 mmHg pressure. What volume will it occupy at 800 mmHg pressure? So in this question, a lot of given values are there. So I have come up with a standard process of solving all the questions with the same process. The very first thing that you are going to do is write down all the things that are given to you under these categories. So I have P1. The first pressure value is given here, mmHg. That's how you identify that this number is pressure by its units. 740 is your first pressure value. Then V1, the first volume value, 2.5 liters. This is your initial volume. You write it down over here in the givens. You copy and paste it from your question and put it down in your givens. And then the next statement says what volume. So volume is our unknown, that is unknown to us. So the final volume V2 is a question mark, and the final pressure is given 800 mmHg. So we have four variables P1, V1, P2, V2. Out of these four variables, three variable values are given and the fourth one is unknown. The next part of the process is equation. We already know this whole assignment will use this equation over and over again. So nothing changes for the equation part. But we have to modify the equation and use a cross multiply to isolate the unknown. Among these four variables, we know that V2 is unknown. So V2 should be isolated. Here is the V2. It is going to be isolated. We let it stay here, and whatever is next to it, we move it to the other side. Since P2 is multiplying on the other side, it is going to divide. So how will my modified equation in the next step will look like? So I will copy what I have already, the other side, P1, V1, I have it here. But now P2 also has joined on the same side of the equation, and the V2 is isolated. So here P2 is dividing. So P1 V1 divided by P2, that must equal to V2. If anybody needs help with equation modifications, we can have a Google Meet on it. But it's just a cross multiply. You are isolating the unknown, so all the given values are on the other side. The second last step is to plug in the values in your modified equation. So P1, we already know what that value is, 740. V1, which is 2.5, and that should be divided by the P2, which is up here in 800. It is very important to extract these values from the question into the given parts. So we are not confused in the statements which one is 1, which one is 2, which one is pressure, which one is volume. So we have already done that part of work in the given part of the process. So you just plug in these values in the calculator and make sure you write your final answer, since we are looking for V2. So V2 will be equal to, I'll show you on our calculator over here. how to solve for this question. So 740 times 2.5 should be divided by 800 and you get 2.31. So the final value is 2.31 liters, and that is your final answer. Because volume is measured in liters, make sure you do write liters, and that's how it should be done. I will show you another question in another video. One thing very important: if one of the pressure values is mmHg, the other one should also be in mmHg. They should be the same units. If one value is measured in liters, your other V2 should also be in liters. If by any chance, I'll show you an example of question number 5. They gave you liters, pressure kPa, one pressure is kPa, the other pressure is in atm. So you will not use different units. You will convert your kPa into atm. Everything should be the same. So because you have already done an assignment before, how to convert kPa to atm, that's why I have this box over here. It tells you the conversion between atm and kPa. 1 atm equals 101.3 kPa. So you will divide your given kPa by the constant. Question number 5, 75 kPa. You will do a side calculation and convert your kPa. So 75 kPa should be divided by the constant 101.3. That will give you your pressure in atm. So 75 divided by 101.3. Let me do it here. 75 divided by 101.3 gives me 0.74. I will ignore the rest of the values. 0.74 atm. So sorry, it's a zero, not parentheses. 0.74. So instead of 75 kPa, you will substitute it with 0.74 atm. That's very important for you to know that the pressure units should be the same, and you cannot compare apples to oranges, oranges to oranges, or apples to apples. So make sure the units are same. That's pretty much it. Just to give you a little bit idea about the Boyle's law. Boyle's law, how it's applied in the real life. I will show you this image over here. You see the astronauts. One of them is shrinked, the other one is expanded. When they go in space, space has no air, so there is no pressure. So pressure is zero. When the pressure goes down, the volume goes up. Look, volume means space, not the space like galaxies or outer space. What I space means how much area you are occupying. How much is your size? Size represents volume, length times width times height. That is the volume. This volume expands because pressure is zero in the space. So the space suit adjusts the pressure inside the suit of this astronaut, so it balances out the pressure inside and outside. Otherwise, if there is a hole in the spacesuit, then this astronaut cannot survive because of the air pressure inside building up. So it's very important that you understand the Boyle's law. There is another video that I saw in one of the classrooms. What they did was they used marshmallows, 400 marshmallows, and they squeezed out all the air. So the pressure was zero inside in a container. So because there is no pressure, the size got bigger. Size is volume. Size got bigger, and when the size got bigger, you can see how the the marshmallows expanded. I hope you can hear the people in the video.
All right, class, what are we doing? We are putting marshmallows inside of a vacuum, releasing the pressure so the marshmallows will expand. And then all of a sudden we're going to put the air back in and they're going to shrivel up. It's going to be epic. Okay, let's give it a shot. Awesome. All right. Close the valve. Whoa. There we go.
So this is a vacuum. All the air is squeezed out. The pressure inside this jar is zero. So the volume is increasing because pressure is decreasing.
It's like popcorn. My idea was epic.
They are growing bigger. The size is getting bigger.
Look at the bottom. Dang. They're all squished up against the side. Empty and now it's all folded. Look at that. Look at that. It's an air bubble right there. It looks like a string cheese. Reminds me of Orville Redenbacher.
That's exactly what would happen to the astronaut who goes up in the space because there is no air. He's going to get bigger in size and eventually explode and increase its size.
Keep on going. Oh man, magical popping corn. Look how big it is now, almost all the way full. Okay, stop it. Release. And now we're gonna release the valve. Here we go. It's gonna look at the ones at the bottom.
After you increase the air, the pressure of the air increases and they shrink back. So increase the pressure, reduce the volume. Reduce the pressure, increase the volume. So that's what Boyle's law is all about. I hope that helped. If there is another question, we will have Google Meet this week for you to help with the assignment. I'm posting the assignment today and I'll give you a week for this. Take care, guys. Bye-bye.